is our own Ron Flannery. We've heard from him a number of times before, and we've always enjoyed it, so looking forward to that. Ron is a computer scientist, futurist, and a Red Bank Humanist board member, who we long ago encouraged to come to the board and come to a few meetings, and he's been a very reliable contributor to all that we do. So he's spoken to us many times in the past on the psychology of art appreciation, genetics, artificial intelligence, and today he's going to walk. I didn't think this, so I'm going to have to do this from my memory. Today he's going to present the simulation hypothesis, which assesses the likelihood that we may all be part of a simulation running on somebody else's big computer, right? Let's see. Oh yeah, I didn't take a lot of this stuff. So sorry about that. But so the simulation hypothesis, and why don't you come up and take over? So let's all, while he's come up, let's all have a nice
I'm off mute. Can you hear me?
Yeah.
Yep.
Okay, I've been terribly sick for the past couple of weeks, so if I break into a coughing fit, bear with me. I'd like to thank the programming committee for allowing me to come and talk again, and thank you all for coming. Those of you who have seen me talk before, I especially thank you, because it's an affirmation that I'm not a terrible bore. So I'm going to talk about the simulation hypothesis. And as always, I have an agenda. So what is it? Is it a new idea? Are there arguments against it? Are there arguments for it? Is it possible to prove that it's for real or prove that it's not for real? And then what is the state of our art in the world of simulation? Who else believes in this stuff? Because if nobody with a brain believes in simulation theory, then it's probably bogus, right? And then what are the implications? And then at the end, we'll do our usual back and forth. So this is the guy who first brought it up as a formal proposal. His name is Nick Bostrom. And if you remember when I did my talk on artificial intelligence, Nick Bostrom was the guy that wrote the book Superintelligence. Okay, so he has a kind of a dark mind, because his premise in superintelligence is that we're all going to die horrible deaths, right? So this is another one of his big ideas, and he came up with it in 2003. And basically, it's built on three premises, or five assumptions. He says in the future, enormous amounts of computing power will be available. And that's obviously true. We've seen it all of our lives growing up. And, you know, it started from CRTs and Pong, and it's grown exponentially since then. The costs have been going down at an exponential rate. Compute power and storage has been going up at an exponential rate, and the amount of data available to train artificial intelligence has been going up at an exponential rate. And this exponential rate is going to hit a vertical line in about the year 2045. So one of the first of the five assumptions is that we'll soon be able to simulate consciousness, right? How much computing power would that take? Well, the human mind does 10 to the 17th calculations per second. So if you want to simulate a human brain, you've got to be able to do 10 to the 17th calculations per second. And if you want to simulate 10 billion humans, then you would have to be able to do 10 to the 26th. So to simulate the world we live in would require this many calculations. And that's a 1 followed by 26 zeros. That's a lot of calculations per second. Well, Eric Drexler outlined a system the size of a sugar cube that would do 10 to the 21st. So that wouldn't do 10 billion humans, but it would probably do a billion, right? And Robert Bradbury has conceptualized a planet-sized computer capable of doing 10 to the 42nd. So somewhere in between the size of a sugar cube and the size of a planet, we're going to hit the ability to do this. And it's all based on what technologies we come up with. So the second premise is that a technological society then could eventually achieve the capability of creating a computer simulation that is indistinguishable from reality to the inhabitants of the simulation. Okay, so we run a simulation, it's got 10 billion people in it, they all think they're real. And they can't tell that they're not real. So that might be us, right? And they will run simulations, that's another premise, because there's a value in it. And the first most obvious value is entertainment. I have an Oculus Quest at home, and I spend a bit of time in virtual reality, and I go into simulations all the time. And it's a lot of fun for me. This is a game I used to play called World of Warcraft. And in World of Warcraft, you go in as an avatar, and you can design your own body and what you're wearing and all this stuff. And I've met guys in there that were women and women that were men, and you can't tell the difference, of course. And there are also people in this game who aren't actually people. They're called NPCs, non-player characters. And they have to be there for a reason. They facilitate the game. So you see an NPC, and he'll have like a question mark over his head or an exclamation point. That's how you know he's an NPC. And you go up to him, and he says, I have a quest for you to perform, and he tells you all about it. And then you go off and you do your quest, right? You come back to this guy. You come back to this guy later when you're done, and he says, okay, congratulations, you did your quest. So he's got a little bit of artificial intelligence going, right? Not very sophisticated. Other values, education. Now, when I was playing World of Warcraft, it always ticked me off that I was a mage, so I would do these magic tricks, right? But the magic was me clicking on a button. And I thought, wouldn't this be a hell of a lot better if I had to solve an equation, or if I had to learn a bit of chemistry, or maybe a little bit of physics, or something like that. Then as I go through this game, I could become a physicist, like this guy over here. But no, you know, I just got really good at pushing buttons. But a lot of educational potential in doing that. So you might do a simulation in order to educate a population of kids. So what you can teach them? I mean, obviously, history, right? By sending people, real people, into a simulation where they visit the Civil War, or they visit the Declaration of Independence being written. Another great use of simulations is tourism. You know, if you can't afford to go to the Louvre, wouldn't it be nice to put on the goggles and virtually go to the Louvre and see everything that's there? And if the resolution is good enough, it might actually be better than going to the Louvre. Because when I went to the Louvre, I couldn't get within 20 feet of the Mona Lisa. But in a simulation, I could get right up to it. Here's one that's a little fanciful, but I like it. And bear with me, I may write this book. Suppose we invented time travel, and we want to go into the past and we want to prevent something from happening like the Holocaust, right? But you got to be careful, because if you go back and you do the wrong thing, you could change history and make it even worse than it actually was. So what do? You run a simulation and you try it out, see how it works out, and then when you got the formula just right, then you go back in time for real and fix things. So maybe that's what they'll be doing. You could model economics, you could do market research, you could do some engineering. It could be an art form, because you know, creating a simulated world could be a way of entertaining your friends and family. And it could be a way of testing environmental impacts. Like suppose you ran a simulation and you said, what if there was a world where people drank water out of bottles and actually paid money for it, and they had hundreds of millions of these bottles and they threw them into the ocean? What would be the environmental impact to that population of having microplastic in everything they eat and drink? Might do something, right? So let's try it out before we actually do give them plastic bottles. And then you can do other things like modeling the evolution of species and star systems and galaxies, the behavior of animals, humans, societies, and then of course you could do war games and see, you know, if we set off 1,000 nuclear bombs, will it really create a nuclear winter and destroy everybody on the planet? And we actually do this today. This is a simulation of the creation of the universe that was run on 300 computers over multiple weeks. And why would you do something like this? Well, suppose you believe that you have figured out all the rules of physics down to the tiniest detail, and you want to test your knowledge of physics. So you say, well, let me build a simulation built on my knowledge of physics, let it run, And when it gets to the end, if it looks like reality, then I was right. But if it doesn't look like reality, then I was wrong. And maybe you could see what was wrong in the model, and that would lead you back to what's wrong in your theories of how the universe actually works. So there is a value with simulations, and our descendants, once we've created this world-sized computer, they're going to run ancestor simulations for all those reasons. And a society that could do this wouldn't do it only once or twice, they'd do it thousands of times. Right? Because you don't just play one game, you play a bunch of games. You don't just run one simulation, you run multiples. And then left long enough, these societies within the simulations would eventually be able to create their own simulated realities. So this raises another question, right? Are we at the base reality, like this is it, or are we the simulations of our ancestors? Or did their ancestors create a simulation and they're running a simulation and we're in it? So we could be the third or the fourth or the fifth level down. And I know that's a wacky concept, but let's see if it plays. So we already looked at this. We know technological process isn't going to stop, progress rather. And we know advanced civilizations may or may not destroy themselves. So if there is no simulation running, it could be that every civilization that gets to this level of complexity blows itself away. And that's a good possibility. We talked, when we did the Fermi paradox, we talked about all the great filters and whether we've hit the final filter or not. But some people think we're getting pretty close. Advanced civilizations will want to run simulations, and if there are a lot of simulations, you're probably in one. So, and we can prove that mathematically. So here are the three possibilities for reality. One is that the fraction of human-level civilizations that reach a post-human stage, one capable of running high-fidelity simulations, is very close to zero. In other words, no civilizations ever get to the point where they can actually do this, right? That's one possibility. Therefore, there would be no simulations. Another possibility, well, and if that's true, then we're going to go extinct before we can do it, right? That's the logical conclusion. And in fact, Sir Martin Rees suggests that civilization has a 50-50 chance of making it through the 21st century, which means the probability of you seeing the end of the world is better than your chance of winning the lottery or dying in a motor accident. Okay, that's a pretty dark view of life. But he's no dope. He's the co-founder of the Center of the Study of Existential Risk at Cambridge. And he says we got a 50-50 chance. Another possibility is that the fraction of post-human civilizations that are capable of doing this decide for some reason not to do it. They have some ethical or moral reason not to do simulations. And if that's the case, then there are no simulations. But what would be that strong convergence across every civilization that could come up that says we're not going to do simulations? What would that reason be? And then finally, if these two things are not true, then the fraction of all people with our kind of experiences that are living in a simulation is very close to 100%. Bostrom says he rates this probability about 20%, and that means he thinks there's an 80% probability that one of these other things is true. And he's the guy that came up with this idea. So the trilemma that I just put before you says either we're all going to die, or we're not going to die, but we're going to decide for some reason not to do simulations, or you're in a simulation. So here's the probability. If you've got one simulated mind in the universe and one real mind in the universe, then the probability of you being the simulated mind is 1 in 2, right? It's 50%. So if we have 10 billion real minds, and those 10 billion real minds run 1,000 simulations of 10 billion minds, then it works out that the probability that you're a simulated mind is 0.999. This is not a new idea. It's an old idea. There's this Chinese philosopher, Zhang Zhui, who he dreamed he was a butterfly, and he said, what is the possibility that I'm actually a butterfly dreaming of being a human, or I'm a human dreaming of being a butterfly? Well, it would be a very sophisticated butterfly that could dream he was a human, right? So I think he got that one wrong. But at least he had the idea that someone in a dream thinks they're real. And then they wake up and they say, oh, that was just a dream. But how does he know he's not still dreaming? Descartes in the 1600s, he posed the question in his book Meditations. And his idea was, what if we're just being fed this reality, and that the real reality is something beyond our ken? George Berkeley said, in effect, if you can't see it, it's not real. When I was in college, I read Berkeley, and I said, well, that means there's no Florida, because I don't see Florida. I don't know. I've never been to Florida, so Florida doesn't exist. And I asked my professor, is that it? And he said, yeah, that's it. Religion is all based on the premise that we're not living in the real reality. That's where we go when we die, right?
Yep.
Right? So if you're a Catholic, this is all a simulation for the benefit of God. I had to learn the catechism when I was a kid. Who made us? God made us. Why did God make us? And there was this whole spiel about, well, God made us so that we could adore him in heaven and, you know, all this woo-woo nonsense. But every religion is based on the premise that there is another reality and you're not in it. This is a simulation. In more recent years, there's the mad scientist with the vat. I don't know if you're old as I am, but there was a movie when I was a kid, Donovan's Brain, where he took the brain of a criminal and put it in a fish tank. And, you know, maybe that's what's going on, right? But you know, then you go back to the, well, who's the guy that made the vats with the brains and all that stuff? But there are several hypotheses about reality. There's the computational hypothesis, and this is a relatively new idea. And the premise here is at the bottom of our reality, like this is the base reality, right? And at the bottom of our reality, down at the smallest, most infinitesimal pieces of our reality that you can measure, there's a place called the Planck length. It's the smallest component of reality. And at that low level of reality, at the Planck length, there are these cells that have rules associated with them. And the rules that are associated with these binary bits of reality make them behave in a certain way in relation to each other. And it's that relationship and those rules at the Planck length that made the universe come into existence and drives everything. Okay? And they call that digital physics. So that's a possibility, right? The universe came from just a bunch of rules at a cellular level. And that's called emergence. And if Neil deGrasse Tyson can't make it, I'm going to talk about that in February. Now, Stephen Wolfram took up this idea, and he wrote a book called A New Kind of Science. I bought this book, and it's got to weigh 15 pounds. But in it, he actually ran a bunch of computer models taking these tiny bits and giving them rules and seeing what they would grow into. And believe it or not, they grow into things that look just like lungs, just like trees, just like leaves, just like blades of grass, depending on the rules that you give them. So it's a pretty sophisticated, pretty convincing argument. Then there's the creation hypothesis. God created the world. He lives in the real reality. We live in the simulation. God is outside of physical space-time that we recognize. And he could be anybody. He could be that 400-pound kid that Trump's always talking about.
Could be Trump.
Then there's the mind-body hypothesis. And, you know, this is where we get into the world of woo-woo. But, you know, your brain exists somewhere else, right? Your spirit and your body are two different things. That's a very old idea, too. And then there's the simulation hypothesis, which is actually a combination of all of those things put together. So there is some computational process underlying physical space-time. And we were designed by the creators as a simulation. Or the universe is the computer, right? And that was that binary physics idea. But it all builds up to the same thing. So arguments against the simulation hypothesis. And you know, when I was putting this together, I was talking to my son about it, and he says, "Do you believe this stuff?" And,
Touche.
yeah, and we'll see. So researchers at the University of Oxford had calculated that even just to store the information about a few hundred electrons on a computer, one would require a memory built from more atoms than there are in the universe. And that makes a lot of sense, right? You're going to model something the size of the universe. That means you need a computer that's bigger than the universe. But how can you have that? Because you'd run out of atoms. You can't do it. So that's that argument. Then there's another argument, and this is based on, I can't find it in here, but a massive scale simulation using classical computers is impossible, due to the quantum Hall effect. And the quantum Hall effect is basically this. If it takes a computer, a CPU, to simulate this chair, then I need a computer for every chair that I simulate in this room. And it might take 2 or 3 computers to simulate a human being. So then I need 2 or 3 computers to simulate everybody that's in this room. And then you've got all the people in the world and all the chairs in the world, and you run out of computers really quick because of the quantum Hall effect. And finally, there is no evidence that we are not in the base reality, right? Have we ever seen anything that indicates that we're not the base reality? We have no evidence of other civilizations in the galaxy. I'll talk more about this in a minute. We are living in the only present there is. I mean, we have no way of seeing that there is any way to travel to the past or travel to the future. You know, modern physics says the future doesn't even exist except as a set of probabilities, and the past is a fixed thing. And there is no general artificial intelligence yet, and if it ever happens, it'll be because we invented it. So, you know, is there a simulation? We don't see it. Now let's look at the evidence for the fact that we live in a simulation. And one that I saw recently was solar eclipses, and I thought this was kind of cool. And what it says is, the moon is exactly the right size, traveling at exactly the right speed, and is exactly the right distance from the Earth, such that, and the sun, such that the shadow of the moon obliterates the sun. What a series of amazing coincidences for that to happen. Now, if you were running a simulation, is there a reason why you would want to do that? There might be, because that would convince very early people that the moon is round, and the sun is round, and maybe the earth is round, and the moon is a heavenly body that's moving around the earth, and my God, astronomy, right? So maybe there's a reason that somebody building a simulation would want to do this. And another thing that happens to be true about the moon is if it wasn't here, there wouldn't be any life on Earth. So, good thing that the moon is exactly where it is and how big it is. Another sign for simulation would be premonitions. If people have premonitions, that would be an indicator that maybe something happened in the simulation and you had to roll it back, right? And then some of the people in that simulation, maybe the memory block that represents their memories didn't get totally erased, so they kind of remember the future because they've been there already. So then they have premonitions. And why would you do this? Well, suppose in the simulation you had a guy who was key to what was being simulated, a person who had to be in the simulation so you could get to the answer 42 at the end. And this guy got on a plane in the plane crash and died. He said, oh, shoot. Let's roll back the simulation and give this guy a premonition not to get on the plane. So the guy, he goes to the boarding gate and he says, oh, wait a minute. If I get on this plane, I'm going to die. So he doesn't get on the plane. Sure enough, the plane crashes, he doesn't die. You've heard this story, right? So that's a clue to simulations and us being manipulated by somebody for another purpose. I looked all over Google to find any examples of premonitions that were solid. Couldn't find one.
There is one. There is one.
There is
Sinking-
one.
Sinking of the Titan. It tells the story of the sinking of the Titanic, almost to the point. It was written 7 years before the actual sinking of the Titanic.
What a coincidence. Then there's deja vu. And again, this could be, well, they had to save this guy from getting on the plane, so they rolled back time a little bit. And you walk into a room and you say, man, I've done this before. And you have, right? They rewound it and then they wound it forward again. And you can't explain why you have this feeling. And of course, there are good psychological reasons why you have deja vu too. Then there's past lives. If you were in a simulation and maybe somebody didn't erase a memory block completely and they reused your memory space, you know, you might be born and get to be 12 years old and you got all these memories. Man, I've lived here before. I had a husband in a town 10 miles away and 2 kids. And you've got all these details and you tell your mother all about it and she poo-poos it for 5 years and then finally she says, all right, we're going to go to that town and we're going to see if all of that is got any basis in reality because I want you to stop. So she takes her little girl, Shanti Devi, to the next town. They meet her husband. She goes over to him, knows all about him, knows all about the kids. Everything was exactly as she said it. And this is a pretty well-documented story, and it's really hard to explain unless, of course, you buy into the hypothesis. Then there's the Fermi paradox. Where are the aliens? Well, we're running a simulation on a computer. I don't have enough compute power to simulate 10 billion people 1,000 times and aliens too. And I don't need the aliens to run out the model that I'm running, so I'll just leave them out of it, right? And that explains the Fermi paradox. And then there are the anthropic principles. And to explain the anthropic principles, you got to understand why you have to have them in the first place. And the reason you have to have them is because the world looks like it was designed. If gravity was a little bit stronger, stars would burn out too fast, they would collapse into black holes, the universe would contract. If gravity was a little weaker, we wouldn't have things like solar systems because there wouldn't be enough gravity to hold everything together. If the cosmological constant, which is 1/2 with 123 zeros after it, if the cosmological constant was a little bit different, then the universe would have flown apart long ago, or it would have collapsed into a singularity long ago. If the strong nuclear force was a little stronger or a little weaker, we wouldn't be able to have atoms and molecules. If the weak force, the weak nuclear force, was a little bit stronger or a little bit weaker, again, we wouldn't be able to have atomic particles. The same is true of electron charge and particle mass and about 24 more things. So, if the universe wasn't created, then why is everything so perfectly balanced that we can be here to live in it? And that's where the anthropic principles come into play. There's an X-Men movie where Dr. X is teaching a class and he gives the class a homework assignment. He says, I want you to write up the difference between the strong and the weak anthropic principles. When I heard him say that, I said, oh, man. So there are 3 of them. The weak anthropic principle is the one that I buy into. So I'm not going to talk about that one yet. I'm going to talk about the strong anthropic principle. This is the one that is the basis of all religion. The reason that the world is fine-tuned is so that we can exist in it. That's why. Okay? God made it this way. That's the strong anthropic principle. The weak anthropic principle, what happened? The weak anthropic principle, though, says the reason the universe is perfectly tuned for us to be in it is because if it wasn't, we wouldn't be here to see it. So it's not that it was made this way for us, it's just we're lucky enough that we happen to land in this one out of all the possible universes that could exist. And that's why we're here. And then there's the woo-woo one. This is the participatory anthropic principle. And this is the one that says the universe is a vast consciousness that wants to be aware of itself. And so it has created all of this so that it can be aware of itself and its consciousness, seeking to exist and be self-aware.
I heard Deepak Chopra say that last week.
Yeah.
He says it every week.
I heard he has a headache.
Okay. Another proof for the hypothesis is Donald Trump. And I don't mean that Donald Trump is an example of a good simulation by any means. Sorry. But Donald Trump is an interesting and unpredictable kind of a thing, right? How can we live in a world where you have a guy like Shakespeare who can say things like this about humanity, and then we elect Donald Trump president? I mean, so there's something that just doesn't jive here. There's a cognitive dissonance to the reality that we could live in and the reality we do live in. And my sister's a born-again Christian, and one time I was having a nice long talk with her, and I said, if all of mankind got together and actually thought rationally, we could be living in paradise. And she just laughed. Have you ever met people yet? No, there's that. And then finally, there's quantum uncertainty. And this is where it gets heavy, folks. Bear with me. In 2017, a paper was written on testing the simulation hypothesis. And a Kickstarter campaign was run, and they raised $250,000 to set out to prove that we're living in a simulation or not. Here's a screenshot of the paper. It was written by Campbell, Owadi, Sovajo, and Watkinson, and these are all reputable people. They're not crazy. They're not stupid, and they've got the money, right? So here's the abstract. I'm not going to make you go through that. But basically what it says is the computer has finite resources which must be conserved. Therefore, we're only going to render in our simulation what we need to render when it's time to render it and save all the computing power. So all those arguments that we talked about before, that you couldn't simulate the entire universe because you'd need a computer bigger than the universe to do it, well, you don't really, because you only simulate what you got to simulate at the moment, which is a very, very small subset of all the things you could be simulating. So you're going to conserve your resources. And they say, if you're going to do that, maybe you're going to have a glitch once in a while, right? The premise is, I'm in a computer simulation, I'm walking down a hallway, and I can see the hallway. That's what's being rendered in front of me. I can't see what's behind me, so it's not there. It's not being rendered. And what's around the corner in the kitchen, I'm not going to see that unless I turn the corner, and then it'll be rendered. Now, if it's a simulation and we're conserving power, maybe I'll turn the corner a little too quick and I'll see it flash into existence, or I'll see a dark edge disappear where they didn't catch up with me or something like that. So that's the premise. It's only going to render what's observable to a player, and there is this problem of wave-particle duality, and maybe that's the glitch in the model, okay? So if that's the glitch, can we run any experiments about wave-particle duality and use that as our method? And they also say in the abstract, though, although from a broader perspective, the issue being addressed is the nature of reality, to avoid philosophical positions, the subject of this paper and our test will be limited to the following question: what causes and determines the collapse of a wave function? And I know that's a little hard to wrap your head around. I'll dig into it. So here's what wave duality, wave-particle duality is. You've got an emitter that emits electrons or photons or some quanta-level particle, right? And you send it through a screen that has two slits cut in it. And what happens is these things, these photons, go through the two slits, and they hit another screen in the back, and you get a pattern like is shown up there, which clearly shows that what's going through the screen are waves, and the waves are interfering with each other, and the interference creates an interference pattern, and that's why it looks like it does. But then there's an interesting thing that happens if you put sensors in front of the two slits, and you determine where the quanta are going before they go through the slits, then you get a different pattern altogether. In this case, you get two straight lines, and that clearly indicates that what's going through the slits is particles, not waves. It's particles. So if you're not looking, it's a wave. If you are looking, it's a particle. Well, that's strange. And here's a block diagram of it. Basically, it's this. You've got a particle generator, you've got a detector. If you don't detect the which way, it's a wave. If you do detect the which way, it's a particle. Well, maybe we should put that on the other side of the screen. Maybe that's the problem. So they do that. They now put the detector on the other side of the double slits. Same thing happens. If you detect which way the particles went, it's a particle. And if you don't detect which way they went, then they're waves. So which are they? And why is it if you're not looking, they're one thing, and if you are looking, there's something else? And then here's a third iteration of it. In this one, they arbitrarily throw away 50% of the information they collect. Then the question is, if you throw away the data, is that the same thing as not seeing it in the first place? And the answer is yes. If you throw away the data, it's a wave. And if you don't throw away the data, it's a particle. Very strange. And then, of course, there are dozens and dozens of ways you can test this. And in every case, if you record the information of which way the particle went, it's one thing. And if you don't record it or you throw it away, it's another thing. And no matter how complicated you make these things, it always turns out the same way. Why is that? So a guy named Archibald Wheeler, he decided to test this at a grand scale. He said, maybe the problem is we're in a laboratory, we're looking at very small things, and we're working at very quick latencies, and maybe what we got to do is do this at a grand scale. And he proposed that we could find a quasar somewhere out in space that's emitting light, and we could find one where there's a star between that quasar and the Earth. And what the star would do is the gravity of the star would do gravitational lensing and make this act like a big lens. So we get light coming from the quasar from two different directions around that star. Okay? That's Archibald Wheeler. Again, not a dumb guy by any means. And we found the quasar with the gravitational lensing. This is a picture of it. This is the quasar, okay, being lensed gravitationally. So we've got light from the same quasar coming from two different points in the sky to Earth. And what happens is, if the light comes down one path and it hits this data collector, the collector lights up and says, found it, I just got a particle coming from that quasar 3 billion miles, or 3 billion light years away. That's 3 billion years ago, that was emitted as a particle, and it just came to this collector. And if it comes the other way, the other collector lights up, says, just saw a particle that originated 3 billion years ago as a particle. So that says that the light left the quasar 3 billion years ago as a particle. Indisputable proof. Then what Wheeler says is we'll put a semi-transparent mirror there. And if we do that, then we'll determine whether, if it's a particle, it'll just go right through the mirror. But if it's a wave, maybe we'll get an interference. And sure enough, the two light beams come here, they're out of phase, they cancel each other out, no collector lights up. And this proves indisputably that 3 billion years ago, the life left that quasar as a wave. So the question is, how did it know? How did it know 3 billion years ago that I was going to put that mirror there? So, is this a proof that we're living in a simulation? Well, people that believe in the simulation theory point to this and say, yeah, because how else are you going to explain this? And then other people point at it and say, you just don't understand physics. So, Associate Professor Andrew Truscott, he says, this proves that measurement is everything. At the quantum level, reality does not exist if you're not looking at it. okay? That sounds like a pretty good argument for this whole business we were talking about of saving computer power. Now, these simulations that we're talking about, they don't have to be perfect, right? Because if you look at my laptop here, all you see is the back of it. As far as you're concerned, it doesn't even have a screen or keys or anything, right? Because for you, that's not being simulated. If I turn it around though, then you'll see the screen, because now you have to see the screen. So we have to simulate it for you. And if we don't open it up, you don't know there's a disk drive inside, and it's not being rendered, so we're saving computing power. But if you have to look inside, then we'll render the disk drive and you'll see the chips and all that stuff. So what's the state of our art today? Well, there is a game online. I can't play it because I don't have a computer with enough compute power to run this particular simulation. But this game, No Man's Sky, includes 18 quintillion planets. 18 quintillion planets can be simulated in this game. But they do it using a trick. And the trick is, if you don't go to the planet, we don't simulate. So you could go to one of 18 quintillion planets, but it won't exist until you actually get there. And when you get there, though, it'll have plants and animals and the people on it maybe, and you'll have adventures with them and so on, and you leave, and it goes into memory somewhere, and then if you come back, it gets resurrected from memory, and it's re-simulated for your benefit. So we're actually doing stuff almost at the level that I was talking about before. And then you get questions like, well, yeah, but what about electron microscopes? You know, IBM has actually written the letters IBM using atoms, and they can show it to you through an electron microscope. That's an awful lot of detail. Yeah, but it's not being rendered until you got to see it. That's the answer. And if there's ever an error, we already talked about this, we'll just roll things back. And if you remember something, we'll erase that memory, and not a problem, right? If you really believe in the simulation hypothesis, then all kinds of things suddenly become possible. You know, there's a lot of TV shows today with Marvel characters and flying around and all that stuff, but why not, right? If it's a simulation, why don't we have X-Men and, you know, Ant-Man and all that wonderful stuff? Because the simulation rules don't allow it. We happen to live in a simulation where the rules say, can't do that because of physics and chemistry and all the things that you determine with science. So who else believes this? Well, at the end of his life, Einstein said, space does not have an independent existence. It's clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. It is a function of our conceptual scheme. Space is a function of mind. Eugene Wigner. It will remain remarkable in whatever way our future concepts may develop that the very study of the external world led to the scientific conclusion that the content of the consciousness is the ultimate universal reality. And then there's Elon Musk, and he's the guy that actually started this whole thing becoming a popular kind of thought experiment. He says that you know, our simulation probability is 99.99%. I showed you the math behind that. It's easy to come up with that number. And he says the strongest argument is Pong. 40 years ago we had Pong, 2 rectangles and a dot. Remember that? I played that game. And now, 40 years later, we have photorealistic 3D simulations. I go to a place called AltSpace almost every day, and I hang out with my friends, one of whom lives in Amsterdam, another one lives in London, another guy I hang out with lives in Manchester, England, and you know, I've met people from Australia and Taiwan, and we all go to this simulated reality, and we hang out together and have cool conversations. And he goes on to say, you know, even if technological advancements were to slow down a lot, give us another 10,000 years, we're going to be able to do this stuff. And if we're able to do it, we're probably going to do it if we survive, right? Neil deGrasse Tyson says it's very likely. He says, the day we learn it's true, I will be the only one in the room saying I'm not surprised. He's such an egotist. Ray Kurzweil says maybe our whole universe is a science experiment of some junior high school student in another universe. It is another very, very smart fellow. James Gates. In my research, I found this very strange thing, and this one really hits me to the core. He does studies of string theory and how they relate to particles and events at the very, very lowest level of reality. And while he's studying all of this stuff, electrons and supersymmetry, he found error correction codes in the math. Now, I was a computer scientist, and error correction codes are used to find lost bits of data and restore them on the fly. Wouldn't it be nice if we lived in a reality where lost bits of data could be fixed and restored on the fly? And if you're running a simulation, well, you certainly need that because it's running in a computer. When I worked with mainframe computers, one of the things we used to see all the time was an alpha particle from outer space would come flying through our mainframe computer and flip a bit. And you know, that could cost a bank $3 billion when you flip a bit like that. So we had error correction codes where that data, we'd see it go by and say, oh, there's a bit flipped, flip it back. Turns out, supersymmetry and string theory and error correction codes all go together. David Chalmers says, what is happening lately, and by that he meant the election of Trump, the mix-up of the Oscars with La La Land and Moonlight, and the win of the Patriots in the Super Bowl. Did you watch that game? Clearly it indicates that we're living in a simulation and something is wrong. If Campbell turns out to be correct and we're in a computer simulation, then there is indeed an answer to Einstein's famous assertion, do you really believe the moon isn't there when you aren't looking? And the answer is, there is no spoon. You didn't see The Matrix? In 2019, philosopher Preston Green suggested it would be best not to test it though, because if you find out it's a simulation, well, they just might turn it off. That would be bad.
And I'd say that.
And Max Tegmark says that we should all go out and do interesting things with our lives, because if the simulators get bored, they might turn us off too. So be interesting, be excellent. So what are the implications? Well, this guy says, you know, at the bottom of it all, it's either a computer simulation or the universe is the computer, or there's this digital physics that's going on. So we're all just data. One way or another, we're all just data. So deal with it. So if reality is just information, then we are no more or less real than if we're living in a simulation or not. In either case, information is all we can be. So there it is, folks. So I have a bunch of questions. Is everyone a simulation, or are there players and NPCs? And I like this one, because if this is a simulation and there are players and there are NPCs, obviously the players are guys like Bill Gates and you know, people, the 85 people that own the planet, those guys, those are the real players, and we're all just NPCs for their benefit. Yeah, which explains why they treat us the way they do, right? So then another question, is the universe a computer, or is another computer that's independent from the universe that's running everything? Or is there something else? You know, is it our collective consciousness, the computer? That's the woo-woo explanation. And then there's the question of the base reality. If this is not the base reality, what does the base reality look like? You know, when we create simulations, the people in the simulations don't look real. They're more cartoonish because, you know, rendering the kind of detail required takes a lot of compute power. So are we cartoonish compared to the people in the base reality? And where in the simulation hierarchy are we? If we're not the base reality, how far down the chain are we? And you know, that's a scary thought, right? What if we're 20 levels down? And what if in the second level, somebody trips over the wire and unplugs the computer? And all of those 20 layers just disappear. And what are the implications with regard to morality and ethics? And this is a tough one for me because I don't eat anything with a cerebral cortex because it's a conscious thing and I don't want to destroy a conscious thing for my benefit. But if it's just a simulated conscious thing, then can't I have some bacon? You know? And would it be all right? And then there's the question of what if this is a model and they're modeling a decision point? And what if the decision point is this? We want to run a model where we see if human beings can save the world from the effects of climate change, right? So we're in this simulation. And eventually we're going to get to the point where we either save the world from climate change or we don't. Simulation ends, done, right? Or maybe we pass that point and they're just collating data. And finally, should this change the way we behave? It's not going to change the way I behave, but it depends on what you buy into.
Are you up for some Q&A?
Sure.
All right. Well, so can you, all right. So, a couple rules before we start the Q&A. It is now 11:30. We got half an hour, so plenty of time for questions. Please raise your hand. I'll go around and try and keep the order of hands that I see as they get raised. So just be patient.
Hey, Chris.
And when you
could
use the
bring me a cup of
microphone,
coffee, please? Thanks.
point it at your foot. You can't hear me like this, but when you do this, you can hear me fine. So, all right, here we go.
Great talk.
Thanks.
Good to see Bob here. So one obvious question that pops at least into my head is, why do we feel pain? Why do we feel joy, emotions? Like, you could run a simulation without any of these beings feeling anything.
What the
They
Catholic
could just
Church
behave
told
as-
me was that the Lord works in mysterious ways. Oh, no, thanks. It's good. Yeah, I don't know. When my son asked me the question, do I believe this stuff? At the time he asked me, I said, I don't know, because I was in the midst of doing all this digging, and some of the evidence is pretty good, and some of the evidence is ridiculous and non-existent. Personally, I don't believe it's a simulation, and it's like I have lower back pain, and if this is a simulation, well, I got something to say to the people running that simulation. Yeah.
Because this also begs the question of free will versus determinism. And people who are strong determinists, I say, well, did you think of that? Or were you programmed to say that?
Well, did you ever hear of a random number generator?
Yeah.
Yeah, well, Apple, back when they came out with the iPod, they had a random number generator in the iPod that said, when you play songs at random, we'll run the random number generator and it'll pop up a number and we'll go get that song and you'll listen to it. So, it looked like they had a winner, but then people started complaining that they heard the same songs all the time. Because in a world of random number generators, they're not really random. They do have a pattern. They will always have a pattern. Because no matter what algorithm you use to generate the random numbers, there's always going to be a pattern in there.
Does that apply to the human mind? I know
Well,
we do patterns, yes, but we also sometimes break out of that.
Yeah, but there's a random number generator in your head, I mean, anything you think about, even it's deterministic, there are alpha particles flying through space that go through your brain. Yeah.
Hi, Ron. That was a really great lecture. Thank you for that.
I'm not lecturing.
That was a great talk, and I definitely enjoyed it.
Okay, I am talking.
Recently, I came across this idea. Have you ever heard of the Mandela effect?
Oh, yeah.
And I found it really interesting. It's been around now, I think, around 3-ish years or so. And the people who really believe in it, are really dug in.
Okay, you want to explain for everybody what the Mandela effect is?
As I understand it, the Mandela effect is certain people will all of a sudden come across something that is very common, like the design of a company logo or lyrics in a song, and they will remember certain details differently.
Right, well, what, the reason it's called the Mandela effect is because of Nelson Mandela. People will swear to you that he was released from prison years before he was released from prison.
And as again, I heard it was,
And he died in
they
prison.
remember his funeral.
That too,
Yeah,
yeah.
there were a lot of.
There's
people
these,
saying
all
that-
these alternate, I remember it differently than you do. I
Right.
read it in the paper, I remember distinctly.
I found it really interesting only because I know, people have bad memories and our memories are actually really good compared to
What we talking about?
objective facts. But one of them that got me personally was the logo for Fruit of the Loom. I remember it having a cornucopia in the back. And now if you go look it up, you can see all the logos they've ever had and none of them have been.
Never been there, huh?
And it's really strange to me, but I think the most logical explanation is I'm just remembering it wrong. But there are a lot of people bringing up a lot of interesting things like that. So related to what you were talking about in terms of the simulation, things being rolled back, things being changed, error
Yeah.
codes. I don't know, it just sounds interesting. What is your thought? Does that fit in with potential?
I think the human mind is a highly overrated instrument. Dick, I was hoping you'd ask a question, because, because I was gonna make you explain the wave particle problem. Okay.
I just have a comment. I'm like you, I want to get at who's ever controlling me. I envisioned a much different life than the one I had.
Yeah, right?
Yeah, that's all, but it was very interesting. Thank you.
Thank you.
Hi, you started out by talking about the simulating consciousness and you had that number with all the 10th power, whatever it was.
Oh, yeah.
So not to get too existential, but how do they define consciousness in terms of simulating?
Oh, well, suppose, here's what's gonna happen, right? We build computers, and the computers are being used to build the next generation of computer. And they've been doing that since the 70s. When I got into the computer business, we modeled our next computer using the computer we had today. And, we would build a virtual computer inside the computer, and it would run, and it would have problems, and we'd fix them in the model, and then we'd build the actual thing, and it would be perfect, because we'd already debugged it. Then we would take this new computer that we built, and we'd start using that to design the next one. Now, what's going to happen in time is, artificial intelligence is going to get to the stage where the computer will be as good as the engineer that would normally be designing that next computer. And we'll use this computer to just design the whole thing and the software that runs on it and everything. And that new computer then is going to be better than this one that designed it. And then this one that we now have, I'm going to run out of space soon, is going to be so smart that it's going to build a computer that has intelligence in it, and eventually it's going to become self-aware. Right? Because it's just going to have so much computational capability that it's going to take all the input that it's getting, and it's going to start building models of sentient beings, and then it's going to come to a realization, hey, I must be one of them. And it'll build a model of itself, and that model is going to be a self-aware example of consciousness. Right? And that's going to happen. It's just a question of when. Ray Kurzweil says around the year 2045, that's going to happen.
Apparently Microsoft hadn't heard of that.
Yeah, I think he was, and what was the assumption or the basis of the equation was how many calculations or computations per second? What was
Yeah.
the?
The human mind does 10 to the 17th calculations a second in parallel. And that's a key thing, because the brain, the way it works, you've got a visual cortex that's running calculations. You've got an auditory portion of your brain doing its calculations. You've got the prefrontal cortex doing its executive function calculations. All of these things are happening in parallel. So when I say a brain requires 10 to the 17th computations, that's actually a bunch of computers all running at the same time. So, you could build a physical computer that does all of those different functions. And in fact, the computer today has a graphics card that does all the graphics independently of the CPU doing its functions.
All right, great presentation. I
Thank you.
was actually taking notes on the for and the against, so I have a whole bunch of things, but I'll stick with the for one. The one that I know is just wrong, I don't know if you didn't just get to the details, but the solar eclipse issue,
Yeah.
because it really isn't perfect. The orbit is not circular, sometimes it obscures more than this, sometimes it's less, and in fact, the moon is moving away from the Earth, so in the past, you wouldn't have had one at all, in the future you won't, so just wanted to point that out, that's not really evidence for.
Okay, we do not live in a You've convinced me.
During the talk, you, in quotes, generational simulation, was it, or something like that?
Yeah.
I don't know what that is.
Ancestral simulation. It's
There you
like-
go, ancestral. sorry.
Yeah, when we get to the point where we can do this, we're gonna do things like, you're a tourist and you wanna go fight in the Civil War, right? So you get in the chair, you put on the helmet, and we send you into the Civil War. You can be a general, you can be a foot soldier, whatever you wanna be, right? But we're simulating your ancestors. Maybe you wanna go back and be your great-grandfather and see what life was like for him. And that would be an ancestral simulation. And, you know, it seems like a frivolous thing, but if you've got unlimited computing power, why not do things like that, right? Or, you want to see what great mistake led to World War I. So you go back, you do an ancestral simulation, and you get a really good feel for what happened.
Hi, thanks a lot. I mean, you really did a good job of explaining something that I thought would have been otherwise impossible. I think I may have learned something in the last hour, but
Oh my God.
but the question is, will this help me understand the HBO series Westworld better? No.
Not really.
No.
I've watched it like 3 times, I still can't get it.
Hi, great talk.
Thanks.
I'm sorry, I actually missed the first part, maybe you addressed it, but,
You want me to do it again?
now, I think the gist of the talk is more like, are we living in a simulation, right? And, you did cite, like, examples of how we could, be living in a simulation, but is it safe to say that, like, us living in a simulation has the same credibility and same evidence-based, credibility as just simply saying, oh, God did it?
Well, it's the same thing.
Oh, it's the same thing.
Sure. I mean, that's the whole premise behind most religions, is that we are living in a simulation. God made us for some purpose. We're acting out His will. And different visions of God. The one that I was raised with, God is all-knowing, all-powerful. He knows what we're going to do before we do it, and yet we do it anyway. And then we go to hell because we did it, even though He knew we were going to do it. I mean, that's a simulation. That's not a reality, right? And the only reality in that whole scenario is the guy who's watching it all happen. As far as he's concerned, it's a big game show.
So I raised my hand because the whole issue of ancestor simulation, the reason why ancestor simulation is important to the argument is one of the main objections is, well, if I had this all-powerful being, why would He simulate people as opposed to some other creatures or some other reality? But if you hypothesize that there were people somewhat like us long in the past that have gotten more technologically advanced, we can say they would actually be very interested in what their ancestors would have been like. So that's a way of focusing the argument on what, you eliminate that question of why would a all-powerful being be interested in things like us? Because the all-powerful being is an evolution from us and is very interested in people like us. And that's why ancestor simulations is part of the argument.
Sure. Uh-oh, here comes the physics question.
Here we go.
No, nothing. You imply that some entity is in charge of this simulation.
Well, that's one possibility.
Okay, so my question is, then it's sort of like people deciding whether or not God exists. If there's a person or an entity in charge of this simulation, how do we know there's not another entity in charge of the simulator on and on?
Right. It's turtles all the way down.
Computers all the way up.
Okay, one of the problems in my mind with the notion of ancestor simulation or going back in time is, I think Stephen Jay Gould has said this, if you rewind the tape and then run it forward again, you won't get back to the same place where you are now. So where we are now is very much the result of many, many, many decision points and places that are non-deterministic. So there's no way you can get back to where you are now. So yeah, you might go back and kill your grandmother, but you might go back and not kill your grandmother and you still wouldn't be here. Because if you ran the tape forward again. So that's a big argument of why you can't go back in time, simulation or otherwise.
Yeah. But just as a counterpoint to that, if you're running a simulation that's something of a grand scale, like you want to see what a country will do, it doesn't matter at that point whether the individuals recreate their lives or not. It just matters what the mass of the population does. It's like the experiment of what happens if we drop 100 million plastic bottles in the ocean and everybody is absorbing microplastics constantly. It doesn't matter what the individuals are doing. What you're going to see is what happens to the population when they're ingesting all those estrogens.
Right, but you're talking about individuals and how individuals understand the world.
I know. Like I said, I don't believe it.
There's another point here. You talked about quantum probability and determinism. But even in classical physics, it's not well discussed or often discussed. That's not deterministic as well. And the people go back, and this is where the Calvinists got into determinism and the whole idea of free will and stuff. But everybody knows that Newton knew this. People looked at Newton's law and said, wow, the world is deterministic. But Newton couldn't even solve the three-body problem.
Right.
He knew it was not solvable. And it's still not solvable, at least with mathematical equations. And why is that?
Three body.
What body?
Three body.
You want to explain that?
Yeah, sorry.
That's why threesomes are really. They never work out more time. That's why, right?
Could you address also Marlborough sets and Fibonacci numbers?
Why?
The three-body problem is this. Newton worked out the laws of gravitation. He was very successful in predicting the motions of the planets and so forth, and the satellites and whatever, but it wasn't perfect. And the reason it wasn't perfect, he knew this, was it works perfectly if you have a sun and one planet. But as soon as you have a second planet or a moon, then you've got three-body, four-body, five-body, whatever. And it becomes so complicated. Well, it's not the complication. It's the fact that the equations are not sufficient to allow you to predict exactly what's going to happen. And it's still that way. It still can't be done. You can do computer simulation by integrating the differential equations, and you can push it out billions of years, but if you try to push it out too far, it becomes garbage. So that problem is not solved, and it's, as far as I know, nobody knows how to solve it. And I think the reason is, if you think about it with the three-body problem, you have to do more than think about it, you have to know some things, but the point is, for every particle or planet, you have you have 6 parameters. You have momentum and position. So you've got 2 bodies, you've got 12, if you've got 3, you've got 18, and so forth. So there's a trajectory in time as all of those parameters change. The problem is you get to points in those trajectories, some of them, not all of them, where you don't know which way it's going to go. It could go one way or another way. And there's no way of deciding. And that's why the equations aren't sufficient. You can't write down the equations and solve them because if you do write them down, there are places in the trajectories where there's a decision that has to be made, and the equations don't tell you what it is. And it's the same thing going the other way. In other words, it's saying in the future, there's multiple trajectories, but also the past. Things can come back when you work in the past, things can come together in the past to one point in the past. So my point is that even the deterministic equations and the deterministic view have serious problems with it. And nobody knows the answer to that. And I'm not sure whoever the genius simulator is knows the answer to that either. Eventually, we probably will know the answer, but right now we don't.
Okay.
Thank you.
Back here.
It doesn't feel like I'm computing 10 to the 17.
Bring some more quotes.
But about that participatory anthropic principle, was it?
Mm-hmm.
Doesn't it feel like, leaving aside the fact that the universe is creating us to appreciate itself, but doesn't it feel like to you that that's really what's happening, leaving the appreciation part aside, is that aren't we an incarnation or just a realization of the universe realizing itself, or the fact that we have become, I mean, this is maybe not related to the simulation hypothesis, but...
Well, it is in a way. Sure. Well, like I said, in February, I'm going to be talking about emergence. And if you believe that anthropic principle, the idea of emergence actually supports that. We are an emergent quality of the basic nature of reality. And again, it's getting real deep real fast, right? But yeah, we'll talk about that in February.
Considering that there are billions and billions of galaxies with billions and billions of stars and their associated planets and moons, I would be amazed if there weren't a whole bunch of other combinations of planets with their associated moon, with their associated star, that has a perfect, full, symmetry there, that we have a perfect eclipse. I mean, there should be a whole bunch more than just ours, is what I'm saying. Just by the odds. Just the odds have got to be that there are more.
Sure.
So that kind of goes against the guy who's the simulator in the sky writing this program. That just by the odds. That's all I'm saying.
Yeah.
Anybody else have any comments, questions? Glenn?
Thank you. Thanks for your efforts, Ron. I'm one who is not convinced.
Yeah.
And there are so many assertions you make that are just assertions. There's no proof or anything like that about what we're going to be able to do in the future. You're assuming that these lines that you've shown continue to do that. It's just a guess. And so much of what you're saying is just guesswork. And it's an imagination, and I'm intrigued by the fact that there are so many references to war games and computer games and all this. And I guess somebody who's been so involved in computers can't avoid that. But in the nature of things, this has all been so unconvincing, and I think of it psychologically, that I think probably a good name for simulation hypothesis is the rationalization of paranoia.
Yeah, great thought stimulation here. So I have always been totally uninterested in fantasy movies, all the way from Star Wars to X-Men to Avatar, because I feel like movies that depict the society that we live in, what my wife calls boring BBC drama, has enough in it, and I can actually think about that as something real that I might get involved in. So now you're saying I should pay attention to this other stuff because maybe these are alternate realities that maybe I should be thinking about.
Well, I know.
I hope not. I hope not.
Yeah, you got to deal with the reality you're in, right?
Yes, and that's where I feel my attention belongs.
Just a comment. I agree with what you said, but I think as human,
There you go.
just a comment. I agree with what you said, but I think as human beings, there's just a great deal of resistance that we have to the idea that this is a simulation and that we are in it. I mean, it's difficult enough to deal with the life we're living to even conceptualize this. So it's just a comment.
Thank you for a great presentation. One question. If this is simulation, why do we need emotions? Getting rid of them would save a lot of computer power, what do you think?
That's true, but you know, if people didn't have hormones driving emotions, we would all be home watching TV.
Boring TV.
Boring TV, very boring.
No emotions, it's boring, right?
Well, and that's one of the arguments against generalized artificial intelligence taking over the world. If computers aren't built with emotions, then they have no motivation to do anything, right? So why would they take over the world? They're just going to sit there and calculate.
Thank you, by the way. Intellectually, I can accept everything that's happening here with the odds and all that, but I do not want to accept it. All right, I don't want to say believe. I don't want to accept it because predetermination and not accepting that was one of the steps that led me to secular humanism. You know, if somebody knows what I'm going to do, what the hell am I doing? Right. Just to comment on Dwayne, you know, that's sort of the basis of where you're coming from, or is it something else?
I'm not sure I understand the question.
Well, you know, I won't accept this because I can't live knowing that someone else is controlling my destiny.
Oh. Well, okay. So don't accept it, right? I mean, that's your right, and so on. But there is a world of thought that says, you know, if you could step back far enough from reality, where you could see all of history before you, and everything that happened, and everything that's going to happen, and everything you ever did, and everything you're ever going to do, and it's all predetermined, and you just happen to be at this point in that timeline, right?
Mm-hmm.
Then the only option you really have is to have a good attitude about it all, or suffer through it. I vote for the good attitude.
I think two more questions. Yeah.
Okay, one of the things that occurred to me is that this seems like our generation's creation of a new culture. because.
There are people that look at this whole thing as, well, that means I can be reincarnated, you know?
Right, like to me, it's each generation of humans in the past, they've come to, different discoveries about like the nature of the world we live in and how things go, and then they come up with, well, this is what happens. We have these cycles of life and death, and this is reincarnation, or well, we have Jesus and heaven. Each generation comes up with what they think is the latest truth, and to me, the simulation hypothesis feels a lot like that. Like this is our generation coming up with, based on everything we've discovered, physics, chemistry, science, a new form of God.
Yeah.
Well, there's someone out there simulating us, and we need to. And some people will take it to extremes and create, belief systems and rules and rituals with it. I wouldn't be surprised if future generations look back on the simulation hypothesis as a form of religion, kind of like in that horrible sequel to Planet of the Apes. They're worshiping the Great Bomb. That kind of thing.
Yeah.
That's what I thought.
Yeah, sure. People will buy into anything.
Yeah.
One thing I had thought of, when they were saying before, that the solar eclipse, the argument against it being evidence for a simulation is because the calculations show that in the past you might not have had them at all, and in the future you won't also.
Yep.
But it can still be a simulation because all the data points we have about the past, human history, and even the mathematics that we can run back and project forwards, could just be the parameters that we see now.
But my other point was, it's not actually perfect right now.
Right, no, it's not perfect right now, because if it was a simulation, we don't know the reason for it anyway. It's just an interesting thing that we can observe right now. But that wouldn't really matter, because you could still write a simulation where the parameters that led to what we see right now are still coherent.
Sure.
But it still might not mean that it's still not.
Okay, I think I may take that slide out.
All right, there was one last hand up. You good? Two more, all right, last two.
Just for one comment, or maybe two.
All right, last three.
You mentioned if you can't see around the corner, it's not there. But the simulation still has to have a lot of memory of what's there.
Sure.
And I think the amount of memory of even the things you're not simulating would be so huge that you run into problems, the size problem. The other place where I think you're going to run into the size problem is, at least in many places, and probably everywhere, you have to simulate things at the atomic level or even lower. And I think that gets so unbelievably complex. And I don't care how big a computer you have, I don't think you can do it. So, I mean, you made that argument, but I think it's, to me, that's the overriding argument. You just can't get to that level.
Looks like you're missing your chance.
Okay, so I'm going to dispute that, because that would be like people who first developed the computers in the 1950s, where something filled this room up and was less computing power than my watch, saying, oh, that you can never do that. So we don't really know what the technology would be in the future. So I just don't agree with that assertion. The second point, though, I want to make is, I've done simulations, and you don't figure out what the end is, and they're not programmed to do something. So you still have free will within the simulation. I wouldn't make that an angst issue.
It's just accepting you're not.
Yeah, but it's not like your life would be planned from here. Part of the simulation is to figure out what you would do. So you can still do whatever you want.
All right, this is the very last one.
I don't know if my question's worthy of that, but
Make it a good one.
all right. Might it be easier for future intelligent beings just to spin off a new universe? Just like create a new universe rather than create a computer so large and powerful to simulate one?
Well, believe it or not, I watched a video on that very topic yesterday, and it turns out that in the future we may be able to actually spin off a new universe, but what happens is as soon as you spin it off, there's a break in the connection between this universe and that one, and you can't communicate with it or see into it. So you can do it, but it doesn't do you any good.
No entertainment value.
No entertainment value.
The simulation doesn't have to look like a computer game, right? If I have a pet hamster and I put them in a cage, that's a simulation. He's got this little world, and it's, you know, it's a simulation, right? Or if I put kids in a school, that's a simulation. They're not in reality anymore. They're at school, and we talk about, oh, after school you're going to have to go to the real world, right? So it's a low-grade simulation of the sort, right?
I used to talk about that when I was in the Army. Real world.
All right, well, this was nice, heady stuff. I really enjoyed it.